you guys can, or on page 18, if you guys can go down to 4, 5, and 6, I'm going to go in the order that I think is easiest to hardest for this. So if you guys can label 6 is example 1, 4 is example number 2, and 5 is example number 3. And it's okay for you guys to use a calculator on this homework assignment. Okay, and I would say that finals week is the week of the 26th, and we will have exactly one full like Thursday to study for the test and then a Monday. But if you have, I'll start to assign it after you guys take the Unit 4 test, the review. So I'll give you about a week to study for it in terms of time outside of class. Okay, so in example number 6, you guys have our first example. I'll say that these questions, like the whole point of some of the concepts that we learned is to be able to apply what we learned in terms of similarities and similar triangles to real world application. And if we were in class with more class time, because I had you guys on a normal year, the traditional schedule just has more class time than the schedule that we have now. One of the things I had to cut was a shadow project where I have you guys go outside and do an application, one of these problems outside. And I thought of having you guys do it at home, but the problem is you need a partner to do at least one other person to do this project. So if we're back in school in February and we get to the trig portion, I think there's a trig version of it. So I do want to do that with you guys if we have the time second semester and we're back in school. So here you guys have that these problems. I'll say the hardest part of it, if a picture is not given, is sketching the picture. So I want you guys, as best as you guys can when we sketch this initially, to try to come up with what you think the picture looks like. And then I'll talk to you further about what to do if you have trouble with it tonight. Okay, so so for 6, the foot of a ladder is 1.2 meters from a fence. So we're going to picture these ladder problems are famous, and this is maybe your first ladder problem, but they go into Calc BC, these ladder types problems. And they're always like slanted, leaning against something like a building or a fence. And you want to always think whenever you get a ladder problem that it's something to do with triangles. Okay, so the foot of the ladder is 1.2 meters from a fence. That is 1.8 meters high. The ladder touches the fence and rests against a building. So what we want to see when we think about this is that you have a building, and then you have a fence that's next to that building that's shorter. And then on top of the fence, you have like this ladder leaning against the building, but that is touching the fence. Okay, so that's the description that is being provided. And so if you guys want to make that look more like a ladder, you guys want to picture that the ladder is resting against, again, the description here, the foot of the ladder is 1.2 meters from a fence that is 1.8 meters high. The ladder, so the key word here is it touches the fence. So this is the point where it touches the fence and rests against the building. So that the top rests against the side of the building. And then it wants you guys to draw a diagram. All right, so what I'm going to do is have you guys read that again. And these numbers are going to represent lengths of the pictures that you guys see here. And so what we're going to try to focus in on is the fact that this is an application of similar triangles means that you probably want to identify which similar triangles they're talking about. So here I have that the smaller nested triangles that we see with that shared angle on the bottom, we have a yellow triangle, and then I'm going to trace in blue, my blue highlighter, the bigger triangle. Okay, so you have a yellow triangle nested within a blue triangle. Okay, and so those are the two triangles that are similar to each other. And what we want to do is label as best as we can what those measurements represent. So reading that again quietly, can I have you guys go ahead and try to label what you think like the 1.22 is referring to, what the 1.8 is referring to, and then we'll talk about it. So try to label as best as you guys can those units and measures. And this is not drawn to scale. Okay, you guys. So again, not drawn to scale, but it describes the foot of the ladder, which is the bottom of the ladder. So foot of the ladder is the bottom of the ladder, and it's 1.2 meters from a fence. So when they're describing like the distance away from like two objects and the distance away from each other, so this being the fence and the ladder, you're never going to think of it in this sense. Like you wouldn't measure the distance between the ladder and the fence as the hypotenuse. It's always horizontal distance. We measure things horizontally when we're talking about distance. Okay, so this length right here is 1.2. So the first brace that you guys see, that's to denote the distance from the base of the ladder to the fence. And then it says that the fence is 1.8 meters high. So that's the height of it. And what you want to think of is altitude. So this measurement is this 1.8 is the height of that fence. And then the last description says the ladder touches the fence and rests against a building that is 1.8 meters behind the fence. So again, it's distance away, and distance is measured as horizontal distance. And that is the distance between the fence and the building. So that's also 1.8. And again, sorry, not drawn to scale. So then what we do is now we picture all the problems that we've done before. And so if this showed up on your quiz without all the application part of it, you should be able to do a problem like this. So we're going to compare the yellow triangle to the blue triangle. Can I have you guys type into the chat, what do you think the scale factor is of the yellow to the blue? What's the scale factor of the yellow to the blue triangle? And you guys can leave it as a decimal as well. You don't have to reduce this one just because we're using it to apply. What is the scale factor? Very good. Okay, so I'm going to talk about two versions of the answer and then how for this problem, either one of them would have worked. Okay, since I did say yellow to blue, just in conversing with you guys, that's the direction I'm going to go in first. So yellow, whenever I say yellow to blue, it's going to be the base of the yellow triangle first, because that's the one that I have the most information on. I know what the base of the yellow triangle is equal to, and I also happen to know what the base of the blue triangle is. So the base of the yellow triangle is 1.2. So I'm going to say the scale factor is 1.22. The base of the entire blue is the sum of 1.8 and 1.2. So that would give me 3. So 1.2 to 3 would be the correct scale factor. Now, when you're looking at, let's say some of you guys did blue to yellow instead, and you did 1.8 to, or sorry, 3 to 1.2, that's also correct. That's okay to do. I would say that you want to read the directions carefully. If they don't say one way or the other, this one would have gone okay either way. You just want to make sure that on the right-hand side, when you set up the proportion to solve, that it makes sense with what you set up on the left. So if I did 1.2 to 3, yellow to blue, then I'm going to want to make sure I do the same for my setup for the proportion. So in this case, they want me to determine the height of the building reached by the top of the ladder. So I'm going to mark off on my diagram what it is I'm trying to solve for. And the height of the building marked by the top of the ladder to the base is what we're trying to solve for. So that's X. That's the left-hand side of my triangle, my blue triangle. So now if I set up my proportion, can you guys type into the chat, what does the rest of the proportion look like? So if I'm trying to set up a proportion to solve for X, what would that look like? Good. And as you guys are typing that in, you always want to think of it like as if I did yellow to blue, I want the right to be yellow to blue as well. Okay, so the yellow to the blue on the right-hand side would be the 1.8 of the height to the X that I'm trying to solve for. So very good, 1.8 to X. And then from there, once you guys get the proportion, now you guys can solve for it. So with your calculator, can you guys go ahead and solve the rest of the problem here? And what is X equal to? Good, Phoebe and Christian, that's correct. And then don't forget to tie a unit of measure along with it as well. And then also in the chat, if you guys are not getting the 4.5, which is the correct answer, can you type into the chat before I move to the next problem? If there's any questions or clarification I can provide on the problem, like Mrs. Kim, how did you get that? Or can you explain this step again? Can you guys type into the chat if you have a question about somewhere that I lost you on this problem, let me know. I know the other class had questions on it. Does everyone understand how I got the scale factor? The 1.2 to the 3. Okay, and then just don't forget to tie the meters to it. If everything's measured in meters, you want the meters there as well. I looked through your problems, you guys, and and the problems on the rest of your homework assignments has diagrams tied to it. So I think example 1 would have been challenging had you not been able to come up with what that image looks like. So it's good for us to go through that. Okay, so for 4, 4 is another big question. And if you guys want an idea of what second semester is going to look like, I feel like this is a good problem to represent what second semester looks like, because we're going to look a lot at area and volume. And within those problems, we use similar triangles a lot as well. So you have the cheerleaders at City High make their own megaphones by cutting off the small end of a cone made by heavy paper. So if you guys wrap a sheet of paper so that it's cone shaped, in order for it to be a megaphone, they're saying that they cut off this top portion so that there is enough of a space or circular base for you guys to speak through. So they cut off this top cone. And they say if the small end of the megaphone is to have a radius of 2.5 centimeters, what should the height of that cone, what should be the height of the cone that is cut off? So if I had to label what X is going to be, I'm going to read what the question is asking for. And it says the height of the small cone. So height is always measured by what we call the altitude. So I'm going to mark off and highlight that is my X. And actually, let me keep it consistent. I'm going to highlight that yellow. So this is going to be my X. Okay, looking at the diagram, we're on applications of similar triangles. So within the cone, if I were to hold the cone upright and then do a lateral slice right down the middle of my cone, and imagine like a sheet of paper that cuts through the middle of that cone, what I should see is the image of 2 similar triangles. And so I'm going to highlight the yellow triangle being the small triangle. And then the blue will represent the bigger similar triangle. So again, it's nested similar to that ladder problem. Okay, so they gave you guys a few dimensions that I want you guys to pay attention to. 2.5 represented the radius of the smaller circle on top. What's the radius of the, or what's the measure of this base right here, down here, of the blue triangle? What's the measure of the radius of the bottom circle? What's that equal to? So again, if you guys didn't see where I'm referring to, what's the measurement of the base of the blue triangle, which also happens to be the radius of the bigger circle? So very good. You guys said 28 because we can divide the diameter in half to get the radius is 28. And that's important because that's a unit of measure of my blue triangle, which I need. Okay, so I think I have enough information now. Can you guys type into the chat, what is my scale factor for this problem? What's my scale factor? And you do not have to reduce. And actually, let's just to be direct, let's do yellow to blue. And as you guys are typing that out on your quiz, remember for these application problems, you guys can do whatever you want. You guys can do blue to yellow or yellow to blue, just making sure the proportion makes sense with the order that you go in. But for your quiz, if it says, can you write the scale factor of small to big or of this to this, then you want to make sure whatever is mentioned first is going to be in your numerator. Whatever is mentioned secondary is going to be in your denominator. So if I say, can you give me the scale factor of yellow to big, the yellow radius is 2.5. That's going to be the side. The bottom of the yellow and the bottom of the blue is the side that we're going to use as our scale factor because we have the most information on it. So very nice. A lot of you guys put in 2.5 to 28 on that. And with that, we have enough information to solve and set up a proportion. So my proportion would be, now I'm going to look at my x, and that's the right-hand side of the yellow. The right-hand side of the yellow is x. The right-hand side of the blue is 60. So I'm going to set up my proportion as yellow to blue or x to 60. Okay, to the nearest 10th, can you guys go ahead and solve the rest of the problem to the nearest 10th for this one? Good, the ones coming through are correct. Very nice, you guys. So cross multiply when you guys are solving for that, or that's the means extreme property. And we get 5.4 centimeters is the correct answer. All right, our last example. Okay, you have an image over on the right. You remember we want to measure distance as a horizontal distance, and they happen to superimpose this this similar triangle. So I'm going to highlight the yellow to the blue because it's also nested again. So you have that this is your yellow triangle, and then you guys see that there's a blue, and they want you to find the distance between, or the distance, the width of the Brady River. So we have yellow to blue. Okay, and so if I look at what side I have the most information on, where this is the top, this is the left, and then this is just the hypotenuse of the triangles, it looks like numeric wise, I have the most information on one side. Can you guys type into the chat, if I did yellow to blue, what is my scale factor for yellow to blue or small to big? What's my scale factor here? Good. Okay, I scan my two triangles. I find the side that I have the most information on. I have the most information, very good, on the left-hand side of both triangles. 8 to 15 is the correct scale factor. Now let's go back to the image, and they want me to find the horizontal distance, which is what they mean by width. So this is the width that they're asking me to find. So I'm gonna label that as X. It's unknown. That's what I'm trying to solve for. Okay, so can you guys come up with, now X is part of the top of my yellow triangle, as well as my blue triangle. For the top part of my proportion, can you guys tell me what the length of the yellow, the top leg of the yellow? What's the top leg of the yellow? So in other words, what's the length of this? What's an expression for the length of this? Okay, good. All right, so I don't see anyone timesing, which is good. So sometimes I'll see 7 times 8 times x. Remember, if something's 2 inches and then you add on another 3 inches, it's a total length of 5 inches. So we want to add here. So 7 plus x plus 8, or in other words, 15 plus x. So that's the yellow. And we want yellow to blue, yellow to blue. Okay, so can you guys now tell me what is the denominator of this proportion going to be equal to? So we want the top of the blue. Remember, we want the top of the entire blue, right? So if you look at the actual top of the entire blue, it's not just the 28, right? Good, Ava? Yes. Okay, that looks good. Very nice. So we're adding the 43, sorry, we're adding the 28 to the 7 and the x and the 8 to get the entire length of this. Very nice, is 43 plus x. So it's equal to, or over 43 plus x. Just algebra, from here, you guys make sure that you distribute when you have a binomial in your proportion. So 8 times 43 plus x, and then equals 15 times 15 plus x. Can I have you guys distribute and solve for what x is equal to? I think you should get a nice answer for this. Okay, you guys, good job. It is 17 meters. Just make sure that you guys attach the meters, make sure you guys distribute on both sides. I'll leave that there for a moment. Number 1, 2, 3, I think those one should be super easy. So if you guys can try to see if you guys can come up with an answer and type in, let me know. As you guys are doing that number 1 question, there's a question on how I got 43. 43 from that, if you watch my cursor is tracing the top side of the blue. Okay, this is if you didn't understand the setup of the scale factor. Okay, so if you look at the entire thing, it's 28 is this segment here. This is 7, this is 8. 28 plus 7 plus 8 is 43. And let me know if that makes sense. You want to sum up the entire blue. I will also, as you guys are figuring out number 1, put the solutions or the key to this online so that you guys can check your answers as well. Okay, you guys, so the correct answer to that, good for those of you guys who finished, is supposed to be 36 feet. And then very nice. So if you guys, again, just make sure you double check your answers with the key. I'll post it. I'll try to write out the answers right now and post